sure there's an easier way than the way I did it.
Okay.
So the way I was going to do it, the way I thought about doing it, was I'm going to return a Boolean, so true or false, so winner or not. And then I take in a ticket, it's a double, and I generate a random number using math random for that ticket, and then I generate a random number of the winning number using a double. So then, to get an integer from that, I used if-else statements all the way down to 25, but I didn't finish it. So then I split it up into fours, right? So if ticket is less than 0.04, then ticket equals int 1, and so on and so on. And then do the same for winning number, and then compare if ticket equals winning number, return true, if ticket or else, return false. It's a really basic way of doing it.
Why did you use the double? Is that because of math.random?
Yeah.
So why are you accepting a parameter of double called ticket and immediately assigning it on line 80 to a new value?
Because I want to generate a number. So.
Well, yeah, but if you.
Yeah, I see what you're saying. I don't know why I did that.
So you're generating a random number, and then you have another random winning number. So what does the first number represent?
The ticket.
So that each user's, so there's the concept of like a user, right? Like so you're.
Right. So your user's ticket.
So scroll down here on your browser, on the web browser. Okay.
Oh, so actually.
So guess should register that number with that user.
Okay. So I read it wrong. So I could actually have done this just for the winning number then, I guess, right? And then if it equals the guess number, then.
So so we have two methods. We have guess. The job of guess should be to accept a string and a number. Right? The string should be the user name and the number should be the user's guess. Right? Like maybe in a hash map, maybe.
Okay.
That might be useful.
I think I read it totally wrong. Yeah, I just didn't read it carefully.
That's okay. And so pick would pick a random number, and then if that number were shared by, like if that were a number that one of the people picked, say that person won bacon, right? Or blank wins bacon, person name wins bacon, right? So basically, down here we're saying we're going to pick 25 different times and pick out and print out any of the winners. So do you want me to go over this, like do it in front of you guys?
I don't know since mine isn't going to be wrong.
Okay.
So I didn't realize you wanted a method for adding them to the after. So.
Well, it's just it doesn't have to be a hash map. It's just an idea.
Well, I know.
The guess method was supposed to do that.
made a hash map and then added myself.
Yeah.
So that
Okay.
I can test.
Yeah.
So I got it to pick a random number on the pick. So that's how I did it. I'm pretty sure. I mean, I don't know how you test that. So I don't know if it would expand past 25.
Uh-huh.
But the plus one is the part where I was like, maybe not. But I think it would go 0 to 25 without the plus one, right? Which then this should probably be 24.
Yes.
And then here, this is where I got stuck. So I was going to run it for iterate over the size of the lottery hash map, and then if pick equals, but I couldn't get to the value without inputting the name. So how to actually compare is where I got stuck.
Okay.
Because I mean, from there it's just okay, get the name and then return the name.
You get a number. So pick. So you have one pick though for all of, like, you want to pick once, right?
My thought was you pick once, compare that pick versus the entire hash map. Declare who's the winner from there. I didn't realize you wanted to run it 25 times, but you could just expand and add a for loop and run Rich Biatch 25 times.
Okay. I see what you're trying to do here.
But this is where I got stuck, and I realized that I couldn't think of a way to do it, so I would have to reverse course and
Yeah, you
figure
can't.
a different way.
Yeah, you can't. The problem with this is that hash maps are not guaranteed to be, like, they're not iterable. Like, you can't iterate over a hash map. It's just a collection of keys, right? So what you have to do is get, like, the key. Well, the problem with that is that's also a set, which isn't. I also believe is not. You can iterate over a set actually. So like what you do here is you'd say if pick, and by the way, pick needs to happen once, not every time you are comparing here.
Okay.
So you need to put the pick above the for loop. So lottery, I think there's a command called. Actually, you wouldn't even need the for loop yet. What you'd have is a while loop.
Right.
For the entry has next. Here, let's just I'll go over kind of how I would approach this problem. I think you're on the right track, Mike. We just maybe needed more time.
Yeah, like I said, I'd have to reverse course and figure out a different way to go at it. But the while loop makes sense. The while loop has next, and then compare throughout the hash map. Like, while there's next value in the hash map.
Yeah. All right, so let's open up OBS real quick and change our capture device. Many apologies, audience. Switching to display capture. All right. So let's move this into its own package so we can just reason about it all in one space. So it's like lottery. So we have a lottery class, right? Let's just give it its own main method. Because again, I don't want to mess with any of this other stuff. So lottery should have two methods, right? It should have guess. So we have public void guess, and in guess, what that's supposed to do is take in a username and a user input, right? So like string name int guess, right? And what it's supposed to do is register a guess with the lottery, basically, aka like buy a ticket, right? So when you buy a lottery ticket, you specify the values that you are guessing will win the lottery, right? So when you guess, it's like you're saying, hey, I'm Ben. I think that it's going to be 17, or 5, or 4, or 3, or 2, or 1, something like that. Okay. So you have public void pick. So what pick is supposed to do? Let's look at our Iron Java channel. Pick a number from 1 to 25 and announce a winner. Okay. So we don't really need any inputs here. Let's just say generate a random number between 1 and 25 if a user has picked that number, say the user 1, otherwise say nobody won. Okay? And then void, I want to run like maybe initialize, make like 5 guesses, right? And then let's just run the lottery 25 times. Okay? So if I want to make a guess, this method, since it returns nothing, has to have some sort of side effect. Like it has to store the value that you're guessing somewhere. Right? Let's just pick a field that we currently have. So what makes the most sense? We want the users to be distinct, and the values can be anything. It's a pretty clear use case for a hash map, right? So let's say we have a private hash map string integer guessers. I just want to initialize it to a new hash map to begin with. Okay. Actually, let's do this. Let's make it a map. A map is an interface that HashMap implements. So a HashMap implements map, but if you make your variable type map, you're guaranteed to, whenever you use guesses, it's going to be usages of the map interface and not HashMap. So if you want to swap out HashMap for a different implementation later on, then you're guaranteed to not have to worry about using anything that HashMap gave you. We'll talk more about that in a sec. Like later, like today, we're talking about generics and stuff, and I'll tie that in there as well. Like if I wanted to change this to like the concurrent hash map, I could just change it there, right? And now the hash maps are thread safe, right? But I'm guaranteed to have never used any methods that came only with hash maps because my variable type is map. So like all hash maps are maps, right? So if you're like, I have a variable that's a map. It doesn't know what kind of map it is. All it knows is it's a map. And I'm going to use the map features. Remember we talked about polymorphism? Like where that method does different things based off of the thing that implements that method. So when I call guesses.put, for instance, it's going to use the hashmap put method because hashmap implements map. But if hashmap has like a concrete method that map doesn't know about, then we could never use it in our code, which is awesome. because then if we want to swap out the implementation of HashMap for something else, then we don't have to worry about all the different places that used a HashMap specific method. Does that make sense?
Yeah.
So like using interfaces is always a pretty good idea. So like you'll see like private map or private list string equals new array list, right? That way your code is guaranteed to basically be updatable. It's one of the nifty reasons why interfaces exist. Okay, so I want to register a guess with the lottery. So guesses dot put name guess. Right? So pretty straightforward.
Yeah, it's just how are you, what are you using? Like, how are you passing those parameters in?
What do
Actual name, yes. I would expect there would be like
Oh, we haven't called that yet. So like down here we could be like guess, well, Ben, I'm gonna guess 15, guess Mike.
I got you.
What we'd have to do is make all these static actually, sadly. So Mike, what do you want to guess? 2. And then Lindsay, what do you want to guess? 7. All right. Yeah, you ass.
I was born on the 2nd.
Okay.
It's quad shot. Mocha is
Quad shot.
hell yeah. All right. So generate a random number between 1 and 25. Okay. Say what?
I've never ordered coffee and I probably should order coffee. But I don't really often hear movies like order quad,
Oh, I do.
blah blah blah. So I feel like when you walk out there, it's like, I'm sorry, sir, did you say quad?
Sorry, sir, do you have a problem?
Well, usually they come with 2 shots of espresso, and then I was like, can I get like an extra shot of espresso? And for some, like somehow, like you're like, I don't know. When you get extra espresso, they charge you for 4 or whatever. She's like, you're gonna pay for it anyway, so do you want 4? And I was like, okay. Okay. So that's like half this cup is just espresso. So like it's like having still a very large espresso, basically.
Coffee actually has more caffeine in it than espresso.
Really?
No, like in college, I think. For like you.
So
That random gives you 0 to 1, and then you're multiplying it by 25.
yeah. So I have an idea. Let's do math.seal. Let's do that. Mail.seal. Math.seal.
Sealing.
So like if it's 0.99, you're gonna give us 1. Wait, no, that's not gonna work. I'm dumb. Sorry. Let's back that up. So my beef with this is that math.random returns a number between 0 and 0.99, greater than or equal to 0 and less than 1.
That's why I did the if else statements.
So I think Mike's implementation of this is probably pretty on point, so we can just add 1.
Okay.
Okay.
So
You would never use 25.
Yeah, and we would never have, well, yeah, we would have 1 potentially, but we don't want to have 0.
just get Avery's thing. He asked if there was a YouTuber I can
On Iron Java. Yes, son. God. YouTube. Live streaming. I am streaming, right? Yeah, I'm streaming. Live. You can actually see me doing this right now. Basic info. I don't know how to, like, how do I get the URL? There we go.
Multiply that number by 25 and then add 1.
Yeah. You also have optionally you have zeros. It's like shifting the 0 to 24 to 1 to 25. Right.
So how is it going to fit there? Because you casted it to it. So is
Yeah.
it going around?
No, yeah. When you cast a double to an int, you lose precision. So like, if you have like 25.57575 and you cast it to an int, it's just 25. And you cast that back into a double, it's 25.00000. Okay? So we have a random number between 1 and 25. Okay. So this is the tricky part. We need to see if, basically, we need to look at all the numbers that we have registered in our guesses list, and if that maps up, then we need to print out the name of the winner. So guesses, let's just take a look around at what hash maps have available to us. We have a key set, we have a values here, which is pretty cool, interesting, but it'd be strange to have a list of values without a mapping to their key. We could get a list of keys, but we're really interested in the values. So we have compute. It's like, seems like it might be useful for computing something.
Are you looking at everything that's available for map?
Yeah.
Okay.
Yep.
All right, because I was like, I see stuff that I really wasn't interested in, but that's another reason why you did that, correct?
What?
That you made it a map and not a hash map.
Yeah.
So that you have more methods available to you.
Fewer, actually.
Fewer?
Yeah.
Okay.
So like,
I thought it would be more because it's the broader of the two.
but in programming, if you inherit functionality, you're getting all of those things plus you have the option of adding more. So it's not.
Okay.
It doesn't increase functionality.
It's a more limited scope because every map has to use
those map methods.
Map methods.
If I used a specific implementation like HashMap could have defined a method that I could use here.
Okay.
If I had a map variable. But the downside to that, I mean, it could be that you need to use that, and it's totally fine. But the downside to that is that if you ever wanted to switch out HashMap for something else, you would not just have to switch the type on the variable, you'd also have to switch out like every instance of where you use something that was specific to HashMaps.
Okay.
So like, yes, from a maintainability standpoint, yeah.
Okay.
Like, I can't tell you how satisfying it is to like have used an interface in anticipation of needing to change a concrete type, and then the difficulty level in swapping it out in implementation is like you change a variable, like assignment, and that's it, and it's guaranteed to work. That's a good feeling, right? It's not a good feeling to like have to go through and like be unsure of the things you need to update and stuff like that. It's not super awesome. Yeah. Yeah. So actually, entry set is a candidate here. But we also have a for each. So for each, in this case, and we'll look at what this really means here in a sec. It's a by consumer. A by consumer is a function that consumes two values. And the values that we're going to get here are something that is a superclass of string and something is a superclass of integer. The reason why it says string and integer is because those are the values of the hash map. So this is actually our best bet, hands down. So I'm going to call this key and value, right? So if value equals test, system.out. Printf %s is a winner. And then we'll pass it value, key. So this for each is pretty useful because it gives us access to every element in the hash map. Yep. Our problem is that we need to be able to print if nobody won anything. So you can see this, and then the problem with this is this has to be what's called effectively final. So you can't modify a Boolean value within the context of a lambda expression. But what you can do, or you can't reassign a value. So what you can do is this. Yeah, you can't make a new reassignment. You can't like if you have a very you can't do this basically. You can't have Boolean 1 equals false, and then if this happens, Boolean 1 is true. Then afterwards say like if not 1, then nobody won this time. You can't do that exactly. But what you can do is hack it. So you could say private. Let's say we have another. Private Boolean 1. This is a terrible way of doing it, but I want to just hack this together real quick. We have set 1, so private void set 1 Boolean value. So 1 equals value. So we can say set 1 false, and then maybe it's static. Again, this is all very contrived. So while you can't do variable reassignment, you can run methods, right, and modify existing objects, right? So you can't make something a new value, but you can change the value of something like that. So in here we're saying set 1 is false, and then if this happens, we're setting 1. And if we're at this point in time and we haven't won anything, then we'll say nobody won this time. Again, the third time, this is not an ideal use case, but I'm just hacking something together real quick. So Yeah.
So
Yeah.
Okay.
And so for int I equals 0, I is less than 25, I plus plus, we're going to pick. So that's going to give us a print line statement. Let's do this. Every time we pick, we're going to generate a new random number and see if someone won. So this will tell us the winners for each, like we're going to run the lottery basically 25 different times. So let's run this. So I won once. I won twice, and Lindsay won once.
Yay!
And then
you won. And Mike, you won.
Yeah. That was the big winner.
Yeah.
booyah! I promise I didn't do that on purpose. Let's run it again. So I didn't win any. Oh, I won one this time, and Lindsay won twice.
Yay, let's just leave it
Now
at
this
that.
one's like Lindsay won this time,
Yay! I like this game. That just made my morning.
and then I won. You didn't win any that time. Sorry.
So
Sucks for me.
I just want to see the winning number printed out.
Yeah.
Okay.
That way, there's no way to test it unless you look at it, right?
Yep.
Well, we could
Take
be
it at
throwing
its word.
nobody won this time for number 2. Should be a big fat baby now.
All right. Let's do that then. Let's do printf then, and then let's do %d,
Ooh, there we go.
and then a new line character, and then let's do test.
Alright.
Yay!
Let's get ready.
You won more than. Is there 22 on there anywhere? Because that was going to be my second guess.
Nope.
Glad I did 7.
So the problem with this is that it's killing me. Is that I made everything static because I wanted to just run things in a static context, and I didn't have a separate class for lottery. So this is a kind of a weird design decision time here. But basically, in order to use pick and set one and all these fields and methods, I had to make because I just didn't break it out into its own own class, which arguably should have been done, but. Not arguably, it should have been done. And I would have made like a new object of type lottery and then run its own lottery, right? So yeah, that's how you normally do it. And you could like liberate all these guys, make them non-static, because they should be, like each lottery has its own set of guesses, right? And actually a better way to do this is this. So like, let's get rid of set one. Let's do guesses, and then let's have another, let's do private static set string. No, it's not a set, it's a list string winners equals new array list. Actually, no, it is a set because we have distinct. We have distinct winners, right? Like you can only register, like because of our hash map, you can only have one person with a specific name at a time. So that's the kind of a distinction between a set and a list. It's like a list. It's like a it's a collection, but sets disallow duplicates and lists allow you to have duplicates. So when we pick, let's just do let's get rid of this bull crap. So let's say %s is a winner. In fact, let's not even say that there. Let's say if value is test, let's winners dot add key. Then down here, like winners, let's do winners dot for each. Well, if winners dot size is greater than 0, winners dot for each uh, yes, good catch, sir. Well done.
Okay. I see what you're doing. So basically you're comparing the values from guesses to the test and then creating a new set. Hashtag.
That is sweet.
There's a problem because every time we pick, we're storing the winners here. So this doesn't actually need to be a field. We need to actually make this a local variable. So winners has a meaning from the pick method.
That means like you were.
Sorry?
Why would that need to be a local variable?
Because we're not using winners anywhere outside of pick. And when we had it as a field, we were modifying an existing field, and every time we tested it, it maintained the same set of values as before. So like every time we ran pick, it was like, did you win now? And has anyone ever won? Which we don't care about. I mean, we do. I mean, like we don't. That's not part of our problem. We're like, has anybody won the current lottery, right? And so we'll just do that. And so this is we get a new set of winners every time we pick. So every time we pick, we don't know who's won yet. We don't want anyone to have already won because we're picking something right now. So we're going to like go through all of our guesses, and if the guess matches the test, we add this to our winner. And then if afterwards there are any winners, then we're going to loop through all of our winners and print out the winner name. Otherwise, we're going to say nobody picked a winning number. Does that make sense?
Yeah.
Pretty cool, huh?
Yeah.
I like this a lot more than a second ago. The other one was a hack to get like it working. Now this is like how it probably should have been. I still don't like the fact that we have like a bunch of static methods here, but without breaking it up into its own method, that's kind of a necessity because we're trying to use everything in main. So let's talk about our code from yesterday. We didn't get a chance to
2 days ago.
practice problem.
Oh.
Yes, the string reversal problem.
I have to get it back again, sorry.
Okay. Did you guys get the string reversal problem?
Not in a way that would have been satisfactory. So, because you said no Java lang, which then you run into the immutability of the string.
Yeah.
So I was like, I could reassign the string value, which isn't actually reassigning it. It's just because my approach was break it apart into a char array and then add the chars one at a time.
Sure.
Right? You would have used the variable for whatever I called the string, added char one, then the next time added char two, or depending on the two. You know what I mean? So
Yeah.
it would have been 5 different things.
Let's look at your implementation. And what I'm actually going to do is pretend like I'm interviewing you, okay? And we're going to go over the implementation from that regard.
Okay.
So let's open up OBS and change this from display capture.
I don't actually have an implementation.
Sorry?
I don't actually have an implementation because I stopped once I realized it would be immutable.
Oh, okay.
So, I mean, I can put it back together for you.
No, let's just, never mind. Yeah, I guess we could just, I'll go over a solution real quick for you. Wait, I don't want that. I want to display my video again. Wait, no, I don't want to do that. Display capture. That's what I want to do. Okay, so string reversal.
You should use a string builder, but that's in the Java lang.
No, I didn't say you couldn't use anything in Java lang, man.
I thought you said no Java lang.
No,
Okay.
what I meant was don't use anything that'll do sorting for you.
Oh, okay.
Like,
because I was like, no Java lang, you can't use string builder or string buffer.
I want you to build this in Java, but don't use any of the things that Java gives you.
Well, that's what I was. I thought you were trying to prove a point about like how like we were going to do it that way, run into the immutability of the string, and then it was going to slow down the process, and then you were going to be like, look, that's why you should use string builder. That would be so much faster. But that's what I thought was happening. But
Wow. I mean, you're, dude, like, what you just said, though, is pretty spot on. Because using a string builder is one way you can implement this problem, right? So kudos to you for recognizing that using a string builder is more performant than, modification of an actual string because of the immutability aspect of strings, right? So the fact that you would bring that up in an interview means that that's awesome,
okay.
right? That would be one thing that an interviewer would like be super stoked about for someone who just started Java, especially. So let's go over a couple different implementations, right? So let's look at so we have a public static string reverse string input, right? So the goal of this reverse method is to reverse whatever has been passed into it, right? So you're saying start off with the string builder, right? Okay. And then let's do this. Let's do for int I equal to 0, I is less than input.length, I plus plus. And then we'll do, well, actually, no. For I is equal to input.length, then I is greater than 0. No, greater than equal to 0. This one. I minus minus. See what I'm doing here? Input dot char at I. So that's one way you could do it, right? Let's write a test for it. So let's do source test, main test. Let's bring our test at the bottom here, I think. Test public void reverse test assert. Assert equals. No, append and concat are synonyms. Like they're basically doing the same thing. So main dot. Oh, this is a bad example. I meant to do neb. Main dot reverse then. Then assert equals. In this case, yeah. Spelled your name wrong, Mike. Sorry. Your name is now Maka. All right, let's run these tests. Oh no, I ran my my lottery method again. So I'm gonna go to my run configuration and change what I'm running when I hit Control R. And all my tests pass. So yay, we have a working method. is this as performant as it could be? I will say that this is a decent answer and would get approval from me. However, it's not perfect. I mean, the fact that we're using a string builder definitely gets us a majority of the way there, right? Like it's a pretty fantastic runtime. However, if we're looking for clever solutions to this problem, technically, we're iterating over the entire string when we don't have to be.
Really?
Sorry?
I'm guessing a stream. You turn the input into a stream of chars
You don't
and
have to
then
be.
plug them
You
out
could do that.
as you look at it.
Wouldn't that be the same sort of process though? I mean,
I mean, that would eliminate the fact that iterating over the entire thing.
Yeah, but you still have to, like, even with the stream, if you think about it from a computational complexity standpoint, you still have to iterate through half of the, or not half, you have to iterate through the entire length.
Okay.
Yeah, so like,
It's a different stream.
it's basically doing, like, from a computational standpoint, you have to go over all the elements anyway.
so how would you do this without having to iterate over the whole string? Because how would you compare it otherwise?
Well, what are we trying to do?
Trying to compare return reversing.
But reversal, like, if we think of it like you're swapping characters, right? Like the last character needs to be the first one, and the second to last needs to be the second to last. So you can think of it like take these, swap them, take these, swap them, take these, swap them. Once you get to the halfway point, you could have swapped all the characters up to that point, right? So let's do this one. So we have public static string reverse half string input. Now let's take a look at it. Whoa, what did I do there? That's weird. All right. So first of all, what we'll do here is say char characters equals input.toCharArray. So we're going to convert this to a char array first. Okay. So we're going to do for int I equals 0, I is less than characters.length, I plus plus. Except we're going to do characters.length divided by 2. So we're going to look at all the things up to half of the array. Okay? So if we say I is our ith element, right? So at first I is going to be 0, it's going to be our first character. Our other index, the one we want to swap with I, is at the last index, right? So you'd be like int other idx is equal to characters dot length minus 1 minus I.
Oh, yeah. Okay.
So when I is 1, index is going to be 1 offset. So the goal of the algorithm is to take that character and this character and swap them.
Yeah.
At the end of the day, characters arrays can have a bunch of swap characters, which is the reverse version of your string, right?
So they basically like swap indexes.
We're not going to swap indexes. Well, we're just swapping the characters that live at those indexes.
Right.
Yeah.
Okay.
So like char, we're going to save a temporary variable. So char temp equals characters at I. Then we're going to set characters at I equal to characters at other index. And then characters at other index we're setting to temp. And then we're returning a new string. Do you see what's going on there? Let's do another. Oop.
The test debugger.
Yeah, sure, man. So let's copy this test and then reverse test half, reverse half test. So this is a weird name, but you guys hopefully get it. So reverse half, and then let's do. Well, let's run this again. First of all, let's make sure it works. And it does. Yay! So reverse half. Reverse half. I don't know why it like puts them in this arbitrary order, but let's debug this. Okay, so let's set a breakpoint here. Let's set a breakpoint there, IntelliJ. Thank you. And so reverse half test is debug. We're going to debug this one test, right? So the input's Ben. So characters are B, E, N, right? Let's go here and make sure this is like as maximized as possible. So other index is going to be 2, right? So Ben, index indices in Ben are 0, 1, and 2. Start off as 0, max is 2. Other index is 2. First character is 0, last character 2. So we're going to store a temporary character as whatever is our first character. It's our first value, so it's B, right? And this is the int value of B, right? It's a character code. So we have I is 0, other IDX is 2, so we're going to set the first character to whatever is at this index 2, so N, right? So we've stored a reference to our B, so we're going to replace where we had B with our last character, which is N. Okay? So we look at characters right now, it's N-E-N, right? So now what we have to do is replace this last guy with what was here, which we stored in temp. So we're going to set this other index to temp. Okay? So now it's neb. So characters.length is 1, or is 3, rather. The next time we iterate, it's going to be, wait a sec. Oh, yeah. Characters.length is 3. 3 divided by 2 is 1, and so 0 is the only one that would run, right?
Yeah.
So this is actually an interesting edge case because we did it with an odd number of characters, right? But that'll automatically, because of that, ignore the middle character.
Yeah, because it's the middle character.
Which is fine anyway, because
Say,
It just flips everything on the other side.
right.
yeah.
So that works.
Yeah. So we're going to make a new string out of the character array that we had, because the string constructor accepts a character array, so we can do this. So we neb instead, right?
Okay.
So you see what happened there?
Yeah.
Yes.
We'll do it again for Lindsay. Lindsay's a little bit longer, right? So we have characters L-I-N-D-S-E-Y, and then the other index is 6. That's the last character. We're going to basically do the same swap thing. So we have, at the beginning here, we have, sorry. Yeah. So we still have Lindsay from index 1 to index length minus 1, but the last characters are switched properly. So if we, the I is 1, we're going to target the other index is 5. We're going to specify the other index is, the original one is E, and then E is going to take the value of the last one here. So we have Lindsay here. So it's starting to take form, you see. So if we just go back here to this breakpoint, let's set a breakpoint here actually, and then just hit next. So now we're focused on these guys. We'll hit next, and Lindsay is completely done.
Yeah.
So Mike, EKM, EKI, done. Right? Cool?
Yeah.
It's neat seeing the different ways you can do it.
Yeah. There's a bunch of ways you could do it. But yeah.
I mean, would that be equivocal to half the runtime? Because not quite half, right? Because you're not cutting the steps completely in half,
That's a great question.
but you're just eliminating half of the iteration, so it's got to be significantly
Yes. So,
faster.
in case you didn't hear it, people on the stream, Mike asked, are we having the runtime? In an applied standpoint, yes, we are having the runtime. From an algorithmic standpoint, no. So this is the reason why algorithmic complexity is important. because we are still scaling linearly with respect to n. So the time that it takes to perform this action is still, we have to iterate over a linear set of values. So like n plus 2, we had to iterate one more time, right? So from an algorithmic standpoint, it really doesn't make that much difference, right?
Because you're still going over the same line.
Because you're still increasing linearly with respect to n. So for very large values of n, from an algorithmic standpoint, it's just as good as the other implementation we had.
Could you do it faster then? Is there a way to?
Yes, but you would have to store your string inside of a data structure that is designed for this functionality. So that gets pretty advanced. But this is like going back to our previous discussions around algorithmic complexity and runtime. And an applied capacity, but that doesn't mean that even though this is roughly the same as like it's O of n, right? Doesn't mean that doing this isn't worth it, right? In an applied capacity, like going over like n divided by 2 things with respect to n things is still a good thing, right? It's just so like algorithmic complexity alone is not enough to say like this is a good or bad solution. But it gives you a good guideline, right? So like they're both O of n, but this will give you much better performance because you're iterating over half of the variables. And also, we're not doing any string concatenation, which you mentioned before is bad. It's not like, it's just one of those things. It's a common interview question, is strings are immutable, they're unchangeable, and if you want to add something to a string and reassign it, you're building a brand new string, right? That's one of those things that they ask all the time.
And that's why you would use the SB.
Yeah, the string builder. So the string builder is an object that's designed, it anticipates you having a temporary variable for the string and like continually adding to it. But we're not even using the string builder in this case. We're doing array index swapping, which is the fastest of the 3, right? We don't need any extra memory, and that's another thing. And so we talked about algorithmic complexity from a like just number of operations standpoint. Like the number of operations will scale with respect to the number of inputs you have, but an algorithm also has like memory usages also. So if you think about the string builder guy, you'd have to build another entry in memory to hold the string builder, right? But in this case, the only overhead is 1 character at a time. Like otherwise, it's like you have a character array, which is never changing in size. It's like a fixed width, and you have 1 extra temp character. An interesting fact is if we were, what we could do is make this that we can get rid of that character value completely, that temporary character value.
Yeah.
I'm glad you asked, because now I get to actually do it. All right. So if we're still not satisfied with the memory footprint, which is 1 extra character, which by the way is 1 byte. So we're talking about minuscule, what this is going to be called is premature optimization, or micro optimization. It's when you go into a method and you make a change that has like, for the performance sake, which sacrifices potentially readability for like, a very small gain. So you wouldn't do this in normal use cases.
Is the approach going to be the same? So you're
Yes.
Okay.
Yep.
You're going to eliminate the temp.
Yes. Yep. So stay with me here.
Okay.
All right. So if we have reverse half, let's have another reverse half that does basically the same thing. We're going to use ints instead. So we're getting rid of this temporary variable here. All right. And we're not going to store a list of chars here. We're going to store a list of ints. All right. So what we're going to do is we're going to convert this char array to a string.